So, hey there, guys. We're going to be looking at exercise 7.2, 12th standard NCERT textbook. We're going to be solving them today. So, let's look at what exercise 7.2 is all about. And this is integration by method of substitution, right? So, what does this really have to do? What do you mean by substituting, right? So, let's take an example from the previous exercise. In all of your previous exercises, you just had to look at the formula sheet and then you just had to integrate. You did some math operation, you simplified the equations, you made sure each term was integrable and there was a formula in the sheet and you just applied. But sometimes the formula doesn't really help you to get to the integral. So let me give you an example. So let's say if I were to integrate a value, let's take something like, okay, sine. So you know the formula for integral of sine x dx is equal to minus cos x plus c. I think we all know this. So I'm looking at the formula sheet right over here. So this is the one. Okay. But what if I asked you another question? What if I asked you the integral of sine 4x dx? Now, you do know that there is an integral for sine x, but you don't sine x, but 4x becomes the obstacle over here, correct? So similar to integration, when you were differentiating, similar to integration, while you were differentiating, you had you did something unique, right? And that was the chain rule. So let's look at differentiation first, right? So we can have a clear understanding of what's going on. So let's say let's say y is equal to sine 4x, right? If you wanted to differentiate this, what would you do? You would differentiate on both sides with respect to x, right? So what is the differential of y, right? Differential of y is, as you know, so differential of y is y. You bring, it's the power 1, bring the power 1 minus 1. So it is equal to 1. But because you're differentiating with respect to x, it will be 1, which is the differentiated value of y, right? Plus times dy by dx, correct? I think we all know this. Right? And then how did you differentiate sine of 4x? You apply the chain rule, correct? What did you do? Correct? What you did was you actually took 4x is equal to t. Right? So you said I would differentiate with respect to x as sine t. Correct? But again, this is a function of t and not a function of x. Remember, this means differentiate with respect to x. But t is also a function of x. Right? So how would you differentiate this? So let's see. Now, like over here, you differentiate sine. So what is sine? Sine gives you cos. Cos of t, but it doesn't stop there. Because you're differentiating with respect to x, you write it as dt by dx. Now the issue is, where is this dt by dx? Right? You can get it from this equation. Right? So kind of like a substitution method, which is basically the chain rule. What do you have to do is differentiate t, right? With respect to anything, whatever you like. Right? So let's differentiate with respect to x. So not with whatever you like, I'm sorry. You have to differentiate this equation with respect to x so that this gives you the value of dt, right? Now, why you have to differentiate with respect to x and not to t? So let's try this. Let's differentiate with respect to t. What happens is, if I differentiate, let's differentiate on both sides with respect to t, is that d by dt, remember, because here it's d by dx because I'm differentiating with respect to x. Here, I'm differentiating with respect to t. 4x is equal to d t by dt, right? So what is the differential of t? 1, right? So this would be 1. Now what is the differential of 4x? It would be 4, correct? But it would be dx by dt. The issue is we want dt by dx and not dx by dt. So therefore this becomes wrong. We shouldn't differentiate with respect to t. Instead we should differentiate with respect to x. So let's change that a bit and let's do something like that. Alright, so let's differentiate with respect to x now. And what would you do? D by dx times 4x is equal to d by dx times t, right? Now this is easy because it's with respect to x. You would have 4 on this side, but now you're differentiating here with respect to x and you're differentiating t. So what does t become? It becomes 1 times dt by dx, right? So now you've got your dt by dx and you can substitute, which is 4. And so what does this become, right? And then you can substitute your t back as well. So give me a second, this should be wrong. Yep, correct. You get your substitution back. So what is cos of t? Is cos of 4x times 4. That was how. So kind of like substitution. But what do you call in differentiation is the chain rule. What you call in integrals is the substitution method. So let's see this, how we'll do this. Okay. So now going back, let's try something. All right. So let's integrate this. Right? Let's do this same method. Right? So we know that 4x is the one causing us issue. So what we do is we write 4x is equal to some value of t. Right? Great. We can do that. And let's substitute it back to the equation, right? So that would give us integral of sine t dx. Now, here's an issue. What does, first, let me go back and ask you, what does integral of sine of 4x dx mean? It means that integrate sine of 4x, right? Integrate sine of 4x, that is the f of x, with respect, the dx tells me with respect to x, right? Now what does this equation tell me is integrate sine of t, which is now f of, it's actually f of g of t, because it's really the same thing as this, but only the thing is these two are the same. It's just that now it's a function of g of t, because sine of t is basically 4x, so g of t is 4x. Okay, integrate sine of t with respect to x, which doesn't make sense. We want with, you actually want it to be d of t, so that you get with respect to t. This makes sense. Now how do we get dt is the real question. Okay, so in order to do that, we take this value which we substituted with t. All right, and so what do we do with this? Now the good thing about here is that we can differentiate with respect to x or with respect to t. It doesn't matter on either sides. Okay, so let's do both ways so that we can have a clear understanding. So I'm going to do with respect to x first. Okay, so let's do with respect to x. So with respect to x, what do you get? 4, right? Because this is an x value. So with respect to x, you don't have to worry about putting anything else. Then you write is equal to, now you differentiate t. T is 1, but because it's with respect to x, you write dt by dx. Because t is not x, so it's not with respect to x. Remember that. Right? Now what do you get? What do you get? So what you can do is, you get 4 is equal to dt by dx. Therefore, dt is equal to 4 dx. Just taking this to the other side, right? Multiplying on both sides, whatever. Correct? So you got this equation. So you got your dt value. You can also do it by differentiating with respect to t. All right, so let's see that. So this would become what? Because it's with now this is with respect to t, right? So how would you do this? You would differentiate as normal as it was, the x value. 4 comes out because it's a constant. You would write x becomes 1 when you differentiate, but now because with respect to x, you write dx by dt. And t becomes 1. Again, you got that same 4 dx is equal to dt. Same thing. Right? Not the same thing. Yep, you got the same thing. Correct. You got the same thing. Okay. Now the simplest thing to do, this is just an explanation. All you have to do is, if you want to save some time, is just differentiate on both sides. That's generally what you want to do, right? To save time. So if it is 4x is equal to t, all you have to do is, this is just what I did prior, was just an explanation. Why do you get the dx and how do you get the dt on both sides? So all you have to do is just differentiate them and just write dx next to the x and dt on the t side. So let's do this. So 4x is what? 4 times dx, because x becomes 1, right? And t becomes 1, this becomes dt. As simple as that. Now the thing is, I have to change dx. So dx is equal to dt by 4. And I have to substitute this value in here. Now let's write the whole equation again with respect now. Integral of sine t dt by 4. Correct? Which is basically equal to, now I can take the 4 outside because it's a constant, so 1 by 4 integral sine t dt. Now this makes a lot more sense, right? Correct? Because it is integral of sine of t, which is the function of t right now, or g of t, right? With respect to t. Integrate sine of t with respect to t. So now you've got your perfect equation. Now you can integrate this, right? Because you're not worried. So what is integral of sine of t? Is minus cos of t plus c. So you would get 1 by 4 times minus cos of t, okay, minus cos of t, then plus c. Sorry. Correct? Which is equal to, now you multiply 1 by 4 on both sides, but 1 by 4 times a constant is still a constant, so you just leave it as c. Okay, c represents any constant value. Okay, so which is minus 1 by 4 cos of t plus c. Okay, If I am not mistaken, that should be the right thing. Okay. Now, what can we substitute t as? Now, you want to go back to x, right? Remember, your t over here. Go back here. You can see me highlighting this one. This. Right? Your highlighter, let me do this. This value. Correct? Was t is equal to 4x. Substitute it back. So you remember t is equal to 4x. Substitute this in this equation. You go back to minus 1 by 4 cos of 4x plus c. So now you've gone back to your function of x. This is the method of substitution. Now the only tricky part about this thing is what to substitute. That is the main concern of this exercise. Here's what to substitute, where to substitute, and mainly it is what to substitute from the equation. Like, how did you determine, like a question might pop up, why did you choose 4x? Now, interestingly, it represents whether I can remove all the x values and make it as a function of t and dt. That's what I want to do. And that's why you have to know how to choose your x values properly, right? And assign them to t. So when we're going to do this exercise in the following video, I'm going to start with the examples in the textbook, and then I'm going to go to the exercise. All right? That is going to be the most important thing. We're going to start with the examples because I want to show you when to substitute, how to find that intuition to substitute a value, so that you don't get confused. Okay, should I substitute this or should I substitute that? I'm going to show you what you have to do. So this was just an introduction as to how you're going to solve exercise 7.2, or an introduction to method of substitution. All right? So I'll see you in the next video. Take care.